Hello and welcome to my presentation of Increase in Survivability of Hatchery-Raised Red Drum. The motivation behind this research project is that red drum are recreational sports fish whose population has declined due to commercial fishing. But luckily, due to governmental restrictions, the population decline has eased. Since then, fish hatcheries have been implemented to boost the natural population of the red drum. One such fish hatchery is the Bluff National Fish Hatchery. The season for rearing red drum lasts from August to December with at most 2 rounds of production each season. Water is pumped and filtered before it goes into one of the 5 ponds to eliminate any predators or competition. This process takes about a week. 1 day old red drum fry are added to the ponds about 10 days after the filling process has started. And during the rearing process, plankton samples are taken, daily water chemistries are recorded, and periodically the ponds are sampled or seined to measure the fish and get the size and daily growth estimates. Red drum are raised until they get to a minimum average size of 30 millimeters. Ponds are then drained to collect the fish, which are taken to the surrounding area and stocked in estuaries. To maximize the number of fish stocked into the estuaries, there are a few questions to answer. Is there an ideal average size? Are there particular ponds that perform significantly better than the others? Is there a better time of year or water temperature that tends to produce the most fish? And is there a best starting population? Before we decide that, we need to look at the variables that we can and can't control during this rearing process. The variables that we can control are the day the fish are put in the ponds, the size of the ponds, how much fertilizer and feed that are added to the ponds, and when the fish are harvested. What we can't control are the temperature of the ponds, the salinity of the ponds, and the number of larval fish that are placed into the ponds. To determine if there are any particular parameters that will maximize the number of red drum stocked, the following analyses are to be performed: an analysis of variance or ANOVA, a t-test, both paired and independent, time series analysis, regression or curve fitting, and optimization methods. The following graphs are part of a time series analysis to compare the temperature changes during 2 rounds of production for one pond. Here we have 2 separate years, 2009 and 2010 for pond 2, and 2 separate ponds, which are ponds 5 and 6 for the year 2015. What is obvious is that the temperature of the ponds in round 2 has a trend that tends to decrease for the most part until the end of the rearing process. The next graphs are for the year 2015 for ponds 5 and 6 during both rounds. Since the length of the red drums are measured periodically, there is a need to create a trend line to determine the possible growth rate of the red drum throughout the rearing process. I would like to thank my research advisor, Dr. Cadis, for all her help and encouragement throughout this whole process, as well as Dr. Lyons, who has provided correspondence and background information concerning the red drum and Bluff National Fish Hatchery. Also, I would like to thank Dr. Ross, who is helping me with the optimization theory aspect of this research project. Lastly, I would like to thank the Michigan Space Grant Consortium and Eastern Michigan University for giving me the opportunity to do this research and present today. And here are my references.